Hello. We have the Math 2415 Calculus 3 sample problems for the final exam. So let's take a look here at problem 1. We're going to find the vector PQ between the points P and Q. Super easy. So going from P to Q means you subtract the Q x value minus the px value. So it's negative 9 minus a minus 7. As I wrote here, 2 minus a minus 6. So you get negative 2 and 8. That would be your vector. For some reason they decided to use R as the label here. Don't worry about that. That's not critical. I would have just probably called it PQ. Or really they could have just had the vector there without the R equals in front of it. But the boldface notation indicates a vector. Number 2. A little vector algebra here. We're going to find 2v plus w minus 3u. So here's vector v. 2 times v, so we just double every component in there. So it'll be negative 9 becomes negative 18, 2 becomes 4, negative 6 becomes negative 12, plus w, negative 3, 9, 2, minus 3u. So I just made it essentially plus here, plus a negative. So I'm taking every component and multiplying it by negative 3. So I'm going to get negative 21, positive 9, negative 18, and just add them up term by term. Negative 18 plus negative 3 plus negative 21 is negative 42, and so forth, so on. Add the second components and the third component. And we will get negative 42, 22, negative 28. Very good. Number 3. We have to come up with the length of negative w, and here's w. Actually, the negative w really doesn't mean anything here, unless it was negative 2w or something like that, because the length of negative w is exactly the same as the length of w. So you see, if you take 8, 1, and 3 and make them all negative, and you square them, you're still going to get 64, 1, and 9, and then find the magnitude, so it's the square root of 74. Okay. But yeah, if there had been a coefficient negative really didn't matter, but like 3w or negative 3w, then yeah, we would have dealt with that differently. It would have been 3 times square root of 74. Here's a dot product question. B dot W. 8 times 2 is 16. 6 times negative 2 is negative 12. Negative 9 times negative 8 is positive 72. Add those up, we get 76. Remember, a dot product is always a scalar answer. So in this particular case, answer B and answer D were automatically wrong before you even do the problem, because that can't be the result of a dot product. It can only be from adding vectors together, or a cross product yields a vector. But there's no way those B and D could have been answers to a dot product under any circumstance. Number 5. Angle between two vectors is cosine inverse of u dot v over the magnitude of u and the magnitude of v. U dot v, 3 times 4 is 12, negative 27, add those together is negative 15. The magnitude of u will be the square root of 9 plus 9, square root of 18. And then 4 squared is 16, plus 9 squared is 81, that's 97. So cosine inverse, make sure you're in degree mode, because that's what it's asking for, is in degrees. So just check your calculator. And make sure you keep all this especially in the denominator, make sure when you enter them in the calculator, you wrap parentheses around both of those. Or you can put them under the same radical. You can say the square root of 18 times 97, all under the same radical. And I get 111.04. Alright, I paused the video for that one for a minute so I could just go back and do it in the calculator, and then you can kind of see what it looks like. I just didn't feel like I had to record typing of the elements in there, but it is in degree mode. But see, notice how I kept those two radicals together in their own set of parentheses down there in the bottom. So now the next one does say radians, so you'll still use the same kind of calculator strokes like I did up here, same kind of way with parentheses and everything. You just have to make sure that your calculator is then changed over to radian mode. So U dot V, 7 times 2, negative 9 times 10, that will be negative 76, plus 40 is negative 36. Magnitude of U, 49 plus 81 plus 100 is 230. 4 plus 100 plus 16 is 120. And then that calculates to 1.79 radians. Number 7. Determine whether the vectors are perpendicular. This one's very easy and straightforward. If you do the dot product and the answer equals 0, that means they're perpendicular. Any answer other than 0 means they are not perpendicular. So you do the dot product, 6 times negative 5, 5 times 3, negative 42 plus 15 is negative 27, not equals 0, therefore no, they are not perpendicular. Find the projection of U onto V. Okay, so we're going to need this little formula right down here that we have to projection of U onto the V, which is the subscript. And it's U dot V over the magnitude of V squared times vector V. So let's see what we have here. We've got our vectors U and V. Dot product, easy enough, that'll be 29. And the magnitude of V will be 9 plus 1 plus 9, square root of 19. So the projection of U onto V will be U dot V 29 divided by the magnitude of V squared, so it's the square root of 19 squared. So basically it's 29 over 19. Let's see. Times 3, negative 1, 3. So 29 over 19 times 3, negative 1, 3 will give us give us 87 over 19. Negative 29 over 19 and 87 over 19, which will be that answer A right there. Now it's possible if this is on the list of questions for the final, it could also, just like exam 1 had this question, I believe, where it wanted then the vector, the W2, the other component that's orthogonal to that. Well, all you have to do is just take vector U, which obviously is given, and then you subtract the vector you just calculated right here, and that will give you this vector component that's orthogonal of U, that's orthogonal to V. All right. Number 9, cross product. Just kind of follow the formula straight out here. Okay, we R and V, so I'll just treat U as being R here. So it'll be negative 9 times negative 2, which is 18. Negative 7 times negative 9, which is 63. So it's 18 minus 63. Move over to the middle, U3V1. Be negative 7 times negative 1 is 7. 3 times negative 2 is negative 6. So it's 7 minus a minus 6. Come over the last one, U1V2. 3 times negative 9 is negative 27. And then negative 9 times negative 1 is 9. Negative 27 minus 9. And there you go. So just add those up. Once you get that, that's easy to hear. And you're going to get negative 45, 13, negative 36. Have to kind of be careful. These answers are kind of very similar. The first three are similar looking. So once again, a reminder that, cross product is always going to be a vector answer. It's hard to tell by that answer choice D, but that 0 is bold-faced, meaning that's the 0 vector. So it's not the number 0. The number 0 is impossible for cross product, but not the vector 0. Yeah, it'd be better if I'd rather see if I was using 0. I would just put 0, 0, 0 and list it out that way to eliminate any confusion. Okay. All right, we're going to find a unit vector that's perpendicular to both these vectors. Okay. So when you want to find a vector that's perpendicular, or more often referred to as orthogonal to two vectors, that's just a fancy way of saying cross product. Now this one's asking for unit vector, so we'll have to take our cross product and then convert it to a unit vector. So let's see what we have here. And you just use the same cross product formula from up here. So we've got 1 times -5 is -5. 0 times whatever will be 0. The middle one will be U3V1, be 0 again. Then we have U1V3. 3 times -5 is -15. U1V2, 3 times 0 is 0. And U2V1 will be 1 times -1 be -1. So combine those terms and you'll get a -5, 15, and 1. And you take the magnitude of that vector and you get square root of 251, the magnitude of this cross product, not the vector, magnitude of the cross product. So it'd be 25 plus 225 plus 1. Square root is 250. So it's 1 over 2, square root of 251 times -5, 15, and 1. And this one doesn't look like it's rationalized or anything. But now one thing I want to point out here on this problem is that really there's two acceptable answers here. Because it could be the vector going the opposite direction, meaning as long as you don't change the value of the numbers. Either you make the outside one negative or you change all those to negative. But fortunately, if you take all the reverse of these numbers of this vector, you get 5, -15, -1. So you see that has a -15 and a -1, but it has a -5. So that's why that one can't be right, thank goodness, because if that was a +5, in reality, that means both B and C are correct answers. They're just going in the opposite direction. So that's why it would just be C in this case. Number 11. We want to find the direction angle for a vector, and wants the angle between 0 and 360 degrees. So to find this direction angle, it's telling you here is to use, it's like finding the angle between two vectors, except one of them is just going to be the I vector, 1, 0 along the x-axis. So going like this, like that, that's one vector out of, so it's like finding the angle between two vectors, but it's identifying that I is one of them. So like say then and then the other whatever goes like this, and then we'll figure that out. So a little tricky, but once you see what to do, it's not too bad. So I'm essentially using the angle between two vectors formula we saw earlier. The magnitude of this vector A is square root of 26. Now the magnitude of I is 1, so in the denominator you'll just have the square root of 26. So it's like the square root of 26 times the square root of 1, of course, is just the square root of 26. So in the numerator we would have u dot v, or in this case a dot I. So -1 times 1 is -1. 5 times 0 is 0. And I don't know if I would worry about what I wrote right here. I think this is probably the more straightforward way to do it. Is just take cosine inverse of -1 divided by the square root of 26, because we're using, let me scroll back up here. So you can see that formula right here. All right. So cosine inverse then of negative 1 of the square root of 26 will yield you 101.3 degrees with magnitude of the square root of 26. Unit vector in the direction of theta. Okay, that's basically just using the unit circle. You know, the whole idea of a unit circle means the distance from the origin to any point on that circle is if you draw a vector, it's going to be a unit vector. It's going to be a length of 1. So all you do for this one, when they just give you the angle only, it's just taking the cosine of the angle, the sine of the angle. So cosine of 60 is 1/2. Sine of 60 is the square root of 3 over 2. So it looks like C will be your answer here. All right. Not too bad. Let's come down here to number 13. Force 13 pounds, suitcase making an angle of 30 degrees. Express the force in terms of I and J components. So all you do is just multiply the magnitude times the cosine of the angle, and then the magnitude times the sine of the angle. And that will give you the vector that represents the force in terms of I and J. I'm sure some of you've taken physics by now, so you're probably used to that. So 13 cos 30, 13 sine 30. It didn't have the exact, 6.5 is an exact answer, but 11.26 is obviously a decimal. But that's what the answers wanted here, so I went with that. Because cosine of 30 is actually the square root of 3 over 2. But, so all right, we're going to make it match this answer B right here. And there we have it. 14. Parametric equations of a line through the points. So I'm going to create, now all you really need to do this is you need either 2 points like we have here, or a point and the direction vector the line is going. So this one we have to create our direction vector from the 2 points. So I'm going to get that PQ direction vector. So 3 minus negative 1 will be 4. Negative 6 minus a minus 1 is negative 5. 3 minus a minus 7 is 10. So those are your coefficients, and here's the formula right here. Or, well, yeah, for this set of equations. And so 4, negative 5, and 10 are going to be your coefficients of t. And then your, since we're kind of going P to Q here, you can actually use, it wouldn't be wrong, I guess, to use Q as the point here. But it's when you're checking answers like this, you probably can expect it to be the first point listed as the starting point. So they're using negative 1, so it's negative 1 plus 4t. The next one's negative 1 minus 5t. And negative 7 plus 10t. So since Q is on that same line, if you put in 0 into this, that's going to give you P. Then if you put 1 into this right here, that's going to give you the point Q. You can check that out if you want to, but not too difficult. You don't have to. So obviously, in other words, I'm trying to say there has to be a value T that represents both those points, since they're definitely on that line. Number 15, symmetric form. Symmetric form, I'm not a huge fan of symmetric form, but it is good to take a look at it. Sometimes they'll give you information in a problem in symmetric form, so you kind of need to know how to interpret it. I didn't write the thing here, but you could if you needed to, but it's x minus x0 over a, y minus y0 over b, and then z minus z0 over c. So anyway, so the direction vector here, negative 7, negative 4, negative 8, that has to be these bottom numbers. which pretty much narrows the answers down to either B or C. So the numerator then is going to be x minus a minus 4, which will be x plus 4, y minus 8, z minus 3. And that's going to give us kind of close. Got to be careful here, but it's definitely going to be answer B because of that z minus 3 instead of z plus 3. And there we go. We have it in symmetric form in this problem. Number 16, normal equation of the plane. You need a normal vector and you need a point. We have that. So the normal vector, that's your kind of your A, B, C in these equations. So they're the coefficients of the x minus x0, y minus y0, z minus z0. And so 4, 5, 7 will be your coefficients. I just recognize there's a missing parentheses here. Not a big deal, but all right, well, I just put that parentheses in there, but it looks pretty bad, so I'm just going to undo it. But I just wanted you to see there that I did miss that one parentheses. But fortunately, it's not too troubling for the problem. So you see we have 4, 5, 7, and then it'll be x minus 1, y minus 0, and then z minus a minus 7. So I distributed because of the way the answers are. You know, the answers aren't in this standard form. They're in what's called the general form. You're just trying to match what form the answer looks like. If it was handwritten test, you know, I'd probably say leave it in this form. That would be fine. But this is pretty simple algebra. So 4x minus 4 plus 5y plus 7z plus 49. And then it looks like it's got, sometimes it puts the number on the right side, or in this case, they all put 0 on the right side. So now we know where we stand. So the negative 4 plus 49 leaves out a 45, so we just leave 0 right there. And we should have it. Looks like answer C.